Okay, I hope all of you have marked your attendance. Let us see if few more students join or not. In the beginning, I would like to have any queries from you uh, as far as this particular MIPS processor is concerned. We started with the architecture of the MIPS processor. In the last class, we discussed it. So, if you have any query, you can ask it. Otherwise, we shall proceed. Any queries on this in what is taught in the last class? So MIPS consists of instruction memory and data memory. So they are different. Instruction memory is used to store the instructions, that is your program, whereas data memory is used to store the data, whereas there is a register bank, so called registers here. Then there is ALU, that is arithmetic and logic unit. ALU receives the data from the registers, and the output of the register, output of the ALU is stored back into the registers. ALU also performs the operation of data memory address calculation. So in that case, when ALU is used for calculating the address of the data memory, then that address is given to the data memory, and the data can be either stored into the data memory or data can be read from the data memory. Okay, so that is what we discussed in the last class. In addition to this, there are two adders, and these particular two adders are used to calculate the next address that will be stored into the program counter. Program counter, that is PC register, it always contains the address of the next instruction to be fetched from the instruction memory. Usually 4 is added to the current address, and the contents of PC are incremented by 4 to point to the next instruction. But just a minute. But when some instruction is a branching instruction, in that case, either some instructions are to be skipped or some instructions, the execution is to be taken back to some previous instruction. So in that case, either a positive number or negative number is added to the current address, and that particular address is then restored, or it is taken into the PC register. Okay. Then in the last class we saw the use of the multiplexers. Okay, so how multiplexers are used, and there is a control unit inside this particular processor, and the purpose of the control unit is to generate the control signals. So here you can see that the control unit input is taken from the instruction. So it first decodes the instruction. The instruction which is fetched from the instruction memory is decoded, and from the decoded instruction, the control unit is going to generate the control signals. Okay, so it generates the control signal for the registers. It generates the control signal for the multiplexers as to which particular input is to be selected. It generates the control signal for the data memory, whether data is to be written into the memory or data is to be read from the memory. It generates the control signal for the ALU as to which particular operation is to be performed: add, subtract, logical operations, or and, exclusive or, like that. It also gives the control signal to the other parts also, which may not be shown here. Okay, so in addition to this, other control signals are also there. Okay, so let us see how this particular uh, this thing is designed. Okay, so building this particular processor is designed. So that is called building the data paths. How the data flows and what is uh, the actual functioning or the detailed functioning of each of this part of this particular processor. Okay, so data path refers to the data that flows from one element uh, of the processor to the other element. Okay, so element that processes the data and addresses in the CPU. Okay, so these are the registers, then ALUs, then multiplexers are there, memories are there. Okay, so let us see how the data path can be built incrementally between these particular elements. Okay, so we shall define the design of this particular control unit. Okay, so in the beginning, let us consider only the instruction memory. Okay, so the instruction memory contains the instructions. Input to the instruction memory is from the program counter. This MIPS register is of 32 bits, so it's each instruction is of 32 bit, and here the address also is 32 bit. Okay, so depending on how many address lines are there, that determines the size of this particular instruction memory. With 32 bits, there can be 2 to the power 32 locations in this instruction memory. So 2 to the power 32, so that becomes 2 to the power 32. So and each location is of 1 byte. So 2 to the power 32 locations. So this particular instruction memory, if you calculate, it will be of 4 GB, 4 gigabyte. So how it comes? 2 to the power 32 is, it is 2 to the power 2 into 2 to the power 10 into 2 to the power 10 into 2 to the power 10. 2 to the power 10 is 1 kilobyte. So 1 kilobyte into 1 kilobyte into 1 kilobyte, that is 1 gigabyte. And 2 to the power 2 is there, so 4. So 4 gigabytes of instruction memory is available. So out of 4 gigabyte, the appropriate memory location where the next instruction is stored is pointed by this particular PC register, and this particular PC register will select that particular memory location. Then the instruction from the instruction memory, that location, and of course the next 3 locations are also read and enabled, you can say, and the instruction will come out on the outputs of the instruction memory. So output is also 32 bit. Okay, so contents of 4 locations simultaneously. Each location contain 8 bits, that is 1 byte. So 8 into 4 locations. So contents of 4 locations are simultaneously will be available on this particular outputs. So this particular instruction will be of 32 bit. Each instruction of MIPS processor is of 32 bits. So it will come out here on this. Okay. So this is how the instruction is read from the instruction memory. The purpose of the instruction memory is to store the instructions. Okay, so the instructions are stored one after another, and that is group of instruction that constitutes the program. Then out of that, one instruction will come out here, and that particular instruction will be decoded, and it will be executed by the rest of the part of the processor. Okay, so that has not been shown here. But after that particular instruction is decoded and executed, then what is to be done? The current contents of the PC, the current contents of the PC, which is the address of the current instruction. So that is added with 4, and that particular address added with 4 is again stored back into the PC, so that now PC will point to the next instruction. Okay. Usually in one cycle, one instruction is fetched and it is executed. So in the next cycle, what happens? PC is loaded with the address of the next instruction, and that particular address is given to the instruction memory, and then from the next location, the instruction is read from the instruction memory. Okay, so like this, one by one instructions are read from the instruction memory. So this is how the program is executed. Okay, so executing the program is nothing but fetching the instructions. Okay, so fetching the instruction is nothing but giving the address of the instruction to the instruction memory, and memory will send out that particular instruction on its output, and that is received by the remaining part of your processor, and this particular process is called instruction fetch. Instruction fetch. So this is the first you can say step in executing any instruction. Whenever instruction is to be executed, the instruction need to be fetched from the instruction memory. So after instruction is fetched, the next part is instruction decode. The instruction is decoded. Just a minute. माझा क्लास सुरू आहे. So this is the instruction. This is how the program is being executed. Okay, so instruction fetch is one of the important step in fetching, in executing the instruction. Okay, after the instruction is fetched, then next part is decoding the instruction. Okay, now before we go for decoding the instruction, we shall see the different instructions that are available with the MIPS processor. Okay, so there are some instructions which are R format instructions. There are some instructions which are load store type of instructions. Okay, and the third type of instructions, they are the branch instructions. Okay, so we shall see all these three different types of instructions. Okay, the format of this particular instruction right now, it is not included in this particular slide. Okay, so next time I shall include that particular format, and then we shall talk about the instruction formats, and how those instructions, how coding is done in the instruction, and how it need to be decoded. Okay, now for today, because there are less number of instructions, there's less number of students in the class, so we shall stop here. Again, I got a call from the department to attend some meeting. Today we had a very short lecture, and we shall meet again tomorrow in the morning.
For
Okay.
attendance.
Yes, I have already enabled the attendance. Is it not enabled? Did you check?
Enabled, sir.
It is enabled. So you can mark your attendance. And tomorrow we shall see in detail, and we shall proceed with the architecture, internal architecture of the MIPS processor. Okay.
Okay, sir.
So we shall stop here for now. Okay. Right. Mark your attendance, those who are not marked.